With numbers in the denominator, it's a little bit trickier to rationalize the denominator. When there was a letter, it was a little bit easier. Let's take a look and see why it's a little trickier. First of all, we'll break this up into two radicals, one in the numerator and one in the denominator. And then we'll admit to ourselves, man, it would be nice not to have this radical in the denominator. Now, again, one might think, well, if you're going to rationalize the denominator, again, if you remember how to do it with square roots, you simply multiply by the same thing. You just say, cube root of 4 times cube root of 4. Radical and denominator gone, yes? No, definitely not. Sorry, get rid of all that. Doesn't work. Let's go ahead and let's take a look at something that will work. What we can do is we can take the cube, again, let me give you some hints and let's see if you can figure this one out. So what we'd like to have in the denominator is we'd like to have the cube root of something cubed. And then in the end, we'd like to have no radical at all. So the question is, let's use a different color there. So the question is, well, what exactly is it that can go here that can get me something cubed? And that just takes some work to figure out. One way you could try to do it, to figure it out, is you could say, well, 4, rewrite 4 as prime factors, or rewrite whatever the number is as prime factors. So 4 could be written as 2 to the power of 2. Once I do that, it becomes a little bit more obvious. Now I can see that I've got the cube root of 2 squared, and what I'd like to do is multiply that times the cube root of something that gets me a cube inside the radical. So in order to turn 2 squared into 2 cubed, what I'll do is I'll multiply times 2. So we will multiply this 4 times 2. And when we do, we get 8. And let me get rid of this for a second. So I'm just going to write 8. And I'll remind you that 8 is actually 2 cubed. So I'm going to go ahead and get rid of that. And we'll just write that as 2 cubed. Okay, so now the cube root of 2 cubed is 2. And that's a result that we can be very happy with. There we go, just 2. So again, if we want to multiply the denominator by the cube root of 2, we have to multiply the numerator by the cube root of 2. And so what we end up getting is we're kind of stuck with the cube root of 5 times 2. And that'll get us cube root of 10. And again, we're stuck with that even in the very end. That gets us cube root of 10. Let's make that all pretty, make that match. There we go, cube root of 10. And that's it, voila, that is the answer. So again, it's a little trickier with numbers in the denominator. We have to figure out, here's the rule right here. You need to multiply by the least amount to get rid of the radical. And in this case, multiplying cube root of 4 times cube root of 4 doesn't get rid of the radical. I end up with cube root of 16, which is not a perfect cube. So we really need to figure out the number that I can multiply times 4 to get a cube. And when I do, then I multiply by that. And you'll notice in this case, multiplying by 2 was less than multiplying by 4. So I multiplied by the least amount to get rid of the radical. All right, there's your example.